Hello, this is the luckiest maths teacher in the world. Today we're looking at rational and irrational numbers. So as it says on the screen, any fraction can be written as a recurring or terminating decimal, and we call these numbers rational numbers. So all of the numbers we came across in the previous lesson on terminating and recurring decimals, they are all examples of rational numbers. Any fraction that has whole numbers is an example of a rational number. So, examples. We know 1 over 2, which is 0.5. That can be written as a terminating decimal, as a fraction, so it is a rational number. This number here, 4 over 3, it can be written as 1.3 recurring, a recurring decimal, so it's a rational number. Any whole number is a rational number, so 10, 9, 270, they are all rational numbers. Rational numbers can be negative as well. Negative 0.2 is a terminating decimal. It is therefore a rational number. Minus 30 is a rational number. So at this point you're probably thinking to yourself, well, okay, how is this helpful? Isn't all number a rational number? But no, there are numbers that are not rational. You can't write them as a terminating or a recurring decimal or as a fraction. We call those numbers irrational. So irrational just means not rational. And it turns out there are infinitely many of these as well. So the ones that you will probably come across the most will involve square roots. So anytime you square root a number that isn't actually a perfect square, you get an irrational number. So for example, this number, the square root of 2, is irrational. So if you put it on your calculator, depending how many decimal points it goes up to, will tell you it's 1.41421356, and so on, right? So this decimal goes on forever, but there's no pattern to it. It's not like 4 over 3, which is 1.333333. Each number after the decimal point was a 3. There's no pattern to the numbers after the decimal point here. Even though it goes on forever, that means it's not recurring. So it does go on forever, but no pattern to the numbers means that it is not recurring. It's also definitely not terminating, therefore it's irrational. You can't write root 2, square root of 2, as a fraction where both the top and the bottom are whole numbers. So another example of an irrational number would be the square root of 3, because if you put that on your calculator, you will also again see that there is no way to write it as a terminating or recurring decimal. So root 3 is approximately 1.73205008, and it goes on forever. Again, goes on forever, no pattern, therefore it is an irrational number. The square root of 4, however, is rational because the square root of 4 is just equal to 2. Remember, the square root of a number is saying what number do you multiply it by itself to get that number. So square root of 4 is a rational number because 4 is a perfect square. So if you take the square root of a, and a is not a perfect square, then the number is irrational. Any such number is irrational. Remember, perfect squares are 1, 4, 9, 16, 25. So because 1 times 1 is 1, 2 times 2 is 4. That's why 1 and 4 are perfect squares. So 80 is not a perfect square, therefore the square root of 80 will be irrational. I know 100's a perfect square, so square root of 100, which is 10, is rational. Square root of 101, that would be irrational because 101 is not a perfect square. So what we do is we usually write it like this because this is exact form and it's a lot easier than writing out all the decimal numbers. So now that we know what they are, we can use this to find rational numbers between two irrational numbers and vice versa. So let's look at those examples. So in this first question, I'm going to find a rational number that is in between square root of 5 and square root of 6. So that means that it's more than the square root of 5 and it's less than the square root of 6. Now to do this, I do need to write out their decimals a little bit. So the square root of 5, I just put on my calculator. It is approximately 2.236. I only need to write out a couple of numbers, okay? It keeps going on forever, as we know, because it's irrational. Now let's do the same with 6. So if I put the square root of 6 on my calculator, it's about 2.449. Again, it keeps going forever. So I want to find a rational number between these two numbers. So the easiest thing to do is just write any decimal that is terminating between those two numbers, because I know a terminating decimal is always rational. So a number that's more than 2.236 and less than 2.449, how about the number 2.3? That is a rational number. It's more than root 5, it's less than root 6. I could have chosen 2.4. I could have chosen 2.311. That's a rational number too, because it's terminating decimal. So that's pretty easy to find a rational between two irrational numbers. Root 5 and root 6 are both irrational numbers. That's really easy. I just write out their decimals and find a number that's in between. Now I'm going to give you two rational numbers, and you have to find an irrational number between them. Okay, so this one's a little harder. I'm going to find an irrational number between 6 and 7. Of course, both 6 and 7 are whole numbers, therefore they are rational. So the way I'm going to do this is by using the fact I told you earlier. The square root of any number that's not a perfect square is irrational. So I want to change 6 and 7 into square roots. So I know that 6 squared, 6 times 6 is 36, right? So 6 squared is 36. That means that 6 is equal to the square root of 36. If you square root 36 on your calculator, you get 6. 7 squared equals 49. So that means that the square root of 49 equals 7, right? So I want to find an irrational number that's somewhere in between these two. So if 36 is 6 squared and 49 is 7 squared, all those numbers in between are not perfect squares. 37 is not a perfect square. 38 is not a perfect square. 40 is not a perfect square. So if I take the square root of any one of them, I will have a number that's between 6 and 7. And I can use my calculator to double check. So let's just pick any whole number between and not including 36 and 49. So let's try the number 40. So if I take the square root of 40, it will be between 6 and 7, because square root of 36 is 6, square root of 49 is 7. So if you put that on your calculator, the square root of 40 is actually 6.324, and it goes on forever. So the square root of 40 is between 6 and 7. It must be irrational because 40 is not a perfect square. I could pick another number like 42. The square root of 42 will be between 6 and 7 because 42 is between 36 and 49. But 42 is not a perfect square, therefore the square root of 42 will be irrational. So that's another irrational between 6 and 7. So if you're asked to find an irrational number between two rational numbers, remember all whole numbers are rational, the easiest way to do it is by using square roots as I've done. Hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.